So today's topic is a Greibach normal form. In the Greibach normal form, we have three standard production rules. Number one, a production can produce one single terminal. So we can say that if any of the production which is producing one single terminal is acceptable in the Greibach normal form. The production rule number two is the production can produce one terminal and a series of non-terminals. So here you can see that A is producing alpha, where alpha belongs to the terminal, and then beta 1 till beta n, so these belongs to the non-terminals, or you can say variables. So the length of any GF production can be of any size, but it must starts with a terminal. And the last rule is as same as we have done in CNF, Chomsky's normal form, that is a start symbol can produce epsilon, and the condition remains same. It depends on the grammar. If the grammar accepts a null string, then we can say that yes, the GNF can accept a production having epsilon. So let's say few examples. The very first example, G1 shows different productions, and you can see that all the productions are starting with terminal. So we can say that this particular CFG, context-free grammar, is normalized according to Greibach normal form. In the example number 2, we can see that the second production is only producing a non-terminal, which is not acceptable by GNF rules. So that's why we cannot say that this particular CFG is completely transformed into GNF. So here are the conversion steps. The first three steps are as same as what we have done in Chomsky's normal form: the augmentation of the start symbol, the elimination of null productions, elimination of unit production. Step number 4 is completely new for GNF, that is the removal of left recursion. So if any of the production produces in a way that the producer produces itself, so we need to remove that kind of ambiguity. Step number 5, we need to identify the terminals in the production, and only those terminals need to be eliminated with the help of decomposition technique, where the terminals appears either on the second location or somewhere else, not in the first location. And the step number 6 is the substitution of the first appearing non-terminal with its production if it starts with terminal. So what we need in the end, we need every production should start with a terminal. So that is the case in Greibach normal form. The grammar is as same as we have taken in the Chomsky's lecture. So here S produces A as B, and A is producing small a as, and A epsilon, where B is producing as B as A and double B. So the very first step is as same what we used to do, that is the augmentation of a start symbol. So we are simply introducing a new start symbol. So everything which comes up in the red bold font indicates the new entry or the modification in the grammar. So every time we need to rewrite the whole grammar in order to understand the change. Second step is to eliminate all the null productions. So here is the null production. A is producing epsilon, and we need to identify A on the right hand side of all the productions in this set. So there are three productions which contains A on the right hand side. So what we need to do, we need to substitute A with the help of epsilon, and the new productions are S produces SB, and A is producing AS, and B is producing epsilon. So here you can see that B is again producing epsilon. So it is normal, so we don't need to worry that if we are eliminating one epsilon and it appears into another production, So we need to go through like this. So if an epsilon is moving deep down, so we need to eliminate epsilon in every step, so we can remove all the epsilons accordingly. So we need to eliminate this epsilon as well. So the new grammar states that S dash is producing S and S produces A as B and so on. So here you can see that B is producing epsilon. So whenever we are adding up the new productions, we always rewrite the previous set of productions. So here you can see in the black font phase, these are the previous productions. So we cannot leave these productions. Only the production of A, which was producing epsilon, is truncated. It's removed. So in the result of that removal, we are having 3 new productions which are visible here in the red color. So now recheck the null production. So here B is producing epsilon, so we need to do the same what we have done for A. So we need to identify B on the right hand side of all the productions, and here is the set of production which keeps B on the right hand side. So just substitute epsilon instead of B. So here is a new set of production, and we just need to add these productions with the S entry, and here we removed epsilon. So the epsilon has been removed because these productions comes up due to the removal of epsilon. So just keep remember this thing, whatever we are removing must be removed from the final set, and what we are producing or getting after the removal of any entry, we need to add those productions to the set of the production. Step number 3, eliminate all the unit productions. So we need to identify the unit productions. And what are the unit productions? Unit productions are those productions in which the production contains one single non-terminal. So these 3 are the unit productions. So the first thumb rule is that if any of the production which is having itself, the producer is producing itself, so we just need to delete this particular production. We don't need to do any other thing. We just need to delete this production because it does not creates any impact. So what we need to do with S dash produces S and B is producing A, so we need to put all those productions of S over here, and we need to put all the A productions over this production. So let's see how we can do it. So whatever is in the S, we are writing in front of S dash because S dash was producing S, and B is producing A. So whatever A produces, this A has been replaced with the productions of A. So B produces A, so this A has been replaced with all the productions which we can see over here. Similarly, in the technically it was S, so what we did, we put all the values of S productions and we replace this S with the productions of S. So this is how we can move on with the steps. So this is as same as what we have done in Chomsky's normal form, so we don't need to worry, and nothing is new in it. So now the new case is elimination of left recursion. So we need to identify the production which contains left recursion. So if S is producing a production which starts with S, so we can say okay, this is the left recursive production. So how we can remove the left recursion? We need to identify the non-recursive productions of that particular producer, and we need to write them over here and followed by a new non-terminal. So this new non-terminal must have a production and it contains this. So the production which is basically containing recursion, we need to write this production over here without S. so it's simple B, and after B the new non-terminal, that is S double dash, is followed B, or there must be a new production, that is simple B. So this is the way we can remove left recursion, and it has been done previously in the parsing techniques. We have studied how we can remove left recursion. So there are different kinds of ambiguities, and in this case we just need to remove the left recursion. We don't need to worry about the left factored productions. So as produces SB has been replaced with these two set of productions, so we are just writing these two production sets, one for S and one for S dash, as the new entries to the set of productions. And now we are moving on towards the structuring of GNF. So what is the structure of GNF? GNF says that every production must starts with terminal. So step number 5, we need to eliminate terminals if they are appearing other than the first place of the production right hand side. So we identified these two productions contains terminal appeared other than the first place. So B is appearing on the second place, so we don't need to see this B. This B is perfect. We always want a production which starts with a terminal. So what we need to do, we need to eliminate this B with the help of some non-terminal. So we are producing a new production, that is X produces B, so we can remove this B with the help of X. So after rewriting the production, we can say that SXS is the new production instead of SBS, so the B has been replaced with X. Similarly, here we are replacing the second B, not the first B, just to keep the production in GNF format. So this is the actual crunch, that sometimes the students replaces both the B. So here this X, later on we need to replace this X with B again in order to have a terminal in the beginning. So why we need to do things again and again? So whenever we are substituting the non-terminals, we must see that the non-terminal should not replace any terminal which is in the beginning of the production. So that is the set of productions so far, after removing those terminals which are appearing other than the first place. So what we need to do, we need to move on to the step number 6, which is substituting the first appearing non-terminal with its production if it starts with terminal. So let's see, the previous set contains different production sets. So for S dash and S double dash and A, B and X. So here we see that X produces B is perfect. All the productions for X starts with B, fine, and there is no production over here which starts with X. So we cannot use this production in order to replace any terminal in the first place. The second set of production, that is A, is producing all the productions starts with terminal. So we can use A if A is appearing in the first place of the production. So if we replace A with the help of these productions, you can see that all those productions will start with small a, that is the terminal. We cannot use B because B contains terminal as well as non-terminal. We cannot use S dash because it contains both non-terminals, even for S and S dash having the same story. So we can only take A in the beginning. So here what we are doing, we are taking A in the beginning, and we need to identify those productions which are having capital A in their production first place. So S dash is producing A as B, so A is in the first place. S dash is producing AS, okay, A is in the beginning, and S is producing A as B, AS, AS, B, S dash dash, and AS, S dash. So what we need to do, we need to put these three production step by step with these productions. So all these three for SB and all these three for S. So here you can see that. So this was technically A. You can see ASB. So A has been replaced with the first production AAS, second AS. So A should be replaced with AAS and then S. So AAS and S. So these two production, from these two production, and the third production is small a and S. So this small a should also replace the other ones. So step by step we need to eliminate things. So here you can see that two productions starts with AAS, fine. Two productions starts with small a, fine. And two productions with AS, here we are. So three productions of A and two productions of S. So 3 multiplied by 2 gives me 6. So the resultant productions must be of 6. So 1, 2, 3, 4, 5, 6. Fine. In the case of S, we are having 4 productions, and every production should be replaced with these 3 productions. So 3 multiplied by 4, 3 multiplied by 4 must be equal to 12. So we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here you can see that we have replaced all those productions which starts with capital A with the productions of A, and every production of A. No, we cannot use only one production of A, and we cannot leave the other productions. So whenever we are substituting A, it should be replaced with all the productions. So here is the new set of production, and the previous one as B remains here. So now we can see that A has been used, and the next production set which starts with terminal is S. So we can take S as our second member, which need to replace those productions which starts with S. So we are taking S for replacing S, and there are two production which starts with S. S dash starts with SB and B starts with SXS. And how many members of S? There were 12 members. So remember this thing, there are 12 members, and here is 1. So it replace all 12 replaces this X, and we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and every production ends with B, which is this one. Similarly for B, it produces SXS. So XS has been in the end of every production, so we here we are mistaking. So this is XS as well over here. So here's the new set. So just remember this set that we are having XS everywhere. So you see that we are having lots of productions in one particular set, and sometimes the productions are identical to each other. For example, S dash is producing AASSB, and here again AASSB. So every production which is appearing again in the similar set, we can remove one of the production because it's a set of productions, and set only contains unique values, not the duplicate ones. So later we will do this job. Now we can see that B is having all the productions having terminal in the beginning, so we can use B. So we used A, we used S. Now the turn is for B. So here's our two productions which starts with B. S dash dash produces B, S dash dash and B, and B contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 productions. So 16 for this part and 16 for the other part. So here is the result. So B, complete B is from this part to here, and the first part, which ends with S dash dash, starts from here till this part. So we are having multiples of productions, so we don't need to worry about why we are having so many productions and how these productions will help. This is the procedure of creating GNF, and always remember this thing, that the normal forms help us in order to compute the context free grammars, as well as to reduce the complexity of understanding CFGs. So this is the final structure of production rules, and finally we can say that the initial CFG, which was S produces A as B, and A is producing A S and A epsilon, and B produces S B S A and B B, can be converted into lots of productions, but every production you can see that it starts with a terminal. So whenever a production starts with a terminal and it appears one time, and the rest of the members are non-terminals, or there is no need of any other member as well, so we can say that these productions satisfies the rule of GNF. So every production contains terminals, or sometimes production only contain one single terminal. So either we are having one terminal and lots of non-terminals, or we are having one single terminal. So that's all for GNF. Thank you.